Hi, everybody. My name is Jo Thompson. I work for Hecla at our Greens Creek mine up here in Juneau, Alaska, and I'm here to talk to you about our automation program. Unfortunately, I cannot present live, but please feel free to write down any questions you might have along the way, and I put my contact information at the end of this presentation. The Greens Creek mine is located approximately 18 miles outside of Juneau, Alaska on Admiralty Island. For commuting employees, we take about a 40-minute boat ride and 40 minutes on a bus each way every day. There is a camp facility down the hill from the mine at Hawk Inlet, but that's primarily used for out-of-town employees or contractors. Here's just an overview of what I'm going to be going over today. So there are four different types or levels of automation that we use at Greens Creek. The most simple type is line of sight remote control. This is where an operator is underground with the loader and just stands to the side out of the way and operates the machine with the remote that you see on the screen here. This isn't the preferred method just due to the increased risk of having the operator near the machine. Our SOP for remote control operation requires the operator to either use an elevated platform to stand from or stand in a notched area along the rib that's on the left side of the machine. That way the operator can step out of the way if the machine were to take off. The next level is teleoperated or teleremote. This is the first level where the machine is operated from a station set up in a safe location. This could be from surface or in a connex set up underground. Our station is set up in our electrical shop at the 920 admin building. Operating teleremote mode still gives the operator full control of the machine. Under this mode, the machine won't stop if it encounters an obstacle, and so this is not the preferred method of operation from the chair. We just prefer that this mode only be used when loading or dumping a bucket because so unfortunately the sensors sometimes inhibit the ability to maneuver the loader when you're trying to get a bucket at the muck pile. So we do make an exception for this type of usage. The driver assist, also known as teleassist, is the next level where the machine actually uses its sensors and scanners to maneuver its way through the underground. At this level, the operator is only in control of the throttle and the brake. They can give slight directional commands as needed at intersections or turns, but for the most part, the machine will keep itself off the ribs as it's driving. This mode is used most when tramming between the muck bay and the muck pile. And then a full automation mode is the highest level that the machine is capable of. This mode takes a significant more amount of prep work. You have to create a mapped route for the machine for to and from your load and dump locations by driving in teleassist, and then completing the validation of the route, which I'll go into more detail on the whole validation process a little bit later. Full automation requires an area in the mine that isn't changing. Otherwise, you have to keep updating your auto route as you're mining. And so if you're taking a 10-foot round every other day, your auto route kind of becomes obsolete really quickly. And so based on the prep work involved in the full automation, we found the best use for it would be just in long hole areas, in areas that don't have significant changes very often, or like the haulage route on the main ramp system. So how it works is the equipment is isolated in automation areas using access barriers or gates. If these gates are tripped for any reason, the equipment will immediately stop all operations, no matter what it's doing. It could be getting a bucket or dumping in the muck bay. It will stop all operations. In these automation areas, each piece of equipment is fitted with a combination of cameras, LiDAR scanners, and sensors that it uses to guide itself through the underground. So the biggest benefit, of course, to using automation is the safety aspect of it. It completely removes the operator from the hazardous area. It also allows for increased productivity during shift change, any outages. It reduces equipment damage and maintenance costs by allowing you to configure optimal gears and speeds based on the route conditions. And then overall, it adds consistency to the operation. So your tonnage, tramming time for the drills, the drill pattern, and then your overall cycle times. With the benefits, of course, come some obstacles. A big obstacle we see at Greens Creek is the difficulty in blending our manual and automated operations. Due to the current state of the technology, the automated operations have to be completely isolated, and Greens Creek was not set up with automation in mind back in the 90s. Our ramp system is very interconnected, so isolating an area for automation would be a huge disruption to the manual operations. There is a pretty significant cost for setting up the equipment and the operator stations and training operators and everyone involved in supporting the machines. It requires a pretty big change in culture and mentality. Mining is very old school industry, so implementing any new technology or change is difficult and a very slow moving process. Has to be navigated carefully just so you can gain everybody's buy-in in the process. Another thing, the technology changes so rapidly, and keeping up with the advancements is vital. However, it can become pretty costly. We recently finished upgrading to Sandvik's ACS 3.0 system, and there's already whispers of a newer system with more features and capabilities. So once that's out, I'm sure we're going to kind of evaluate how it'll benefit us. And like I said, a lot of mines are already well established and weren't designed to accommodate automated equipment. The equipment requires slightly larger drifts to allow for some buffer room for the sensors to keep the equipment a safe distance away from the ribs, as well as design considerations for turn radius and the frequency of turns in the drift. And so these design changes have been implemented into all mine designs moving forward. However, we are unable to go back and modify any of our previously mined areas. Until recently, Greens Creek had 5 Sandvik loaders that were set up with automation. The initial goal was for the loader to have an operator running from surface while the machine is in an unsupported long hole stope underground. The big benefit was to run the loader between shifts during blasting and gas out when personnel is not allowed underground. Depending on the time it takes for the blast gases to clear, this could be anywhere from 2 to 3 hours, closer to 3 hours if operating at the bottom of the mine. If we were to utilize the full automation mode, we could increase productivity by having one operator running multiple machines. The operator could grab a bucket and send one loader on its auto route to tram to the muck bay while switching to the other loader and getting a bucket with that. And then, of course, the maintenance costs decrease by keeping the machines off the ribs and decreasing the amount of damage that occurs. As of right now, we have transitioned down to only 3 automated loaders, just to decrease the amount of machines that we have to maintain. The loaders are primarily being used in the long hole stopes in between shifts, as automation is the only way to mine in those areas, just due to the unsupported ground. But unfortunately, no full automation is being pursued at this time just due to the prep work involved and the decrease in long hole availability in our mine life. Our long hole stopes are slowly becoming few and far between, unfortunately. Now, moving on to the automated haul trucks. Greens Creek had 4 Sandvik haul trucks fitted with automation. This is just an overview, and I'll dive more into detail later on. But the goal for the haul trucks was to operate the fully automated truck between shifts, starting from the bottom of the mine. This would allow for production between shifts with one operator in charge of multiple machines at once. It would also decrease the maintenance costs for the trucks, as you can fine-tune your gears and speeds along the route to minimize the stress, especially on the transmissions. As of now, the trucks are not being used for automation purposes. We've pulled all of the components off the trucks so that it don't get damaged. In the meantime, the project is just temporarily on hold, pending any technology advancements to improve the safety of the interacting equipment. Now onto the automated drills. I'm not as familiar with these as they were outside of my scope of work at the time. But last year we acquired two of these epi-rock drills with the goal of setting up two drills to operate on their own during shift with one operator managing the two. This would allow for increased productivity, a decrease in maintenance costs, and a decrease in overbreak with the use of the predetermined drill patterns. Currently, the drills are still in the implementation and training phase. The operators have been using the auto drill feature with the predetermined drill patterns, and we've already seen a significant decrease in overbreak with some very nice looking tunnels. We have a third drill coming to site pretty soon, I think at the end of this year, and are still planning on completing the training so that we can have two drills set up and managed by one operator. One significant hiccup that we've seen, it seems as though the operator has to manually drill the lifters and the perimeter holes in an effort to limit the damage to the booms as they kind of come close to the ribs on those holes specifically. There's a lot of conflicting opinions on this matter, but as of now, that seems to be what we're expecting to have to do. So that's pretty unfortunate. All right, on to the latest automation project at Greens Creek. We originally started playing around with the idea of automated haulage back in 2017 when we successfully completed a short 1 mile test route from the ramp kind of higher up in the mine out to the portal. This was done after the initial commissioning of the Sandvik multi-light system. After that test, the haul truck project was put on the back burner for a few years as we switched our focus more towards the loaders. But in 2021, the project started back up again. The Greens Creek Life of Mine plan has us continuing to mine deeper and deeper into the mountain. The current haulage route is a little over 4 miles from the portal to the bottom of the mine, which takes roughly 40 to 45 minutes one way. The longer the haulage route will continue to put more stress on the equipment and reducing productivity for mining in the bottom. So the goal for the automated haulage route was to create a perfected route from the bottom of the mine and operate multiple trucks simultaneously. The automated trucks would haul material from the bottom of the mine to the portal between shifts during blasting and gas out. Okay, getting into the more technical side of this, my favorite part. The first step was to start building the map. This was done by mapping the route, which involved having an operator sit in the cab while the truck drives itself in tele-assist and guiding its way up the ramp. This was able to be done on shift since the operator had full control over the brakes if something were to happen. The problem with this initial mapped route is it's very jagged and messy. Since the truck is trying to guide itself, it's taking in a lot of data points and searching back and forth rather than creating a smooth and seamless route. And that brings us to step 2, which is the first editing stage. For a route to be complete, it must be what we call validated. When the route is validated, it just means the truck has successfully run the route with no issues or obstacles and the system is happy with the results. And so Sandvik took the first route mapping data and ran it through a simulation. The initial simulation was actually very effective in finding a lot of the issues in the route. It was able to smooth out a lot of the points to create a smoother path. So after the simulation removed any bugs that it had found, it was time to complete the final editing and field testing. And this is done by running the truck in full automation mode, still with an operator in the cab, so it was able to be done on shift. If it runs into any obstacles or network gaps along the route, you have to stop, correct the issue, and back up and restart the segment. So this was more time-consuming part of the process. After all the segments were validated, we were able to complete test runs in full automation mode between shifts. This also took numerous attempts as we would have issues with route errors, truck maintenance, or gaps in the Wi-Fi coverage. But after weeks of testing and validation between shifts, we were only able to run each half of the truck route due to the time constraints and logistics of shift change. However, I consider the project a success as we have a completed and fully functional automation route, which is the longest automation route in the world at 4.2 miles. But the longer of the two halves was 2.75 miles. In this entire process, we ran into many roadblocks along the way. The logistics of the project was something that fought us every step of the way. Like I mentioned before, Greens Creek is an older mine with a ramp system designed for smaller and non-automated equipment. This made it difficult to validate a lot of the ramp sections that were mined at smaller dimensions that just kept triggering our equipment sensors. Also, while working on the route on shift allowed us more time to complete the validation, it also meant coordinating with the operations group to try to minimize the disruption to their day-to-day work, therefore creating a lot of delays on our side. A big issue we saw in between shifts was the coordination involved with different departments. The entire ramp system is closed during blasting. However, early on in the gas out, certain groups are allowed back underground as their work areas are in fresh air. So, like the mechanics and the electricians are allowed to go back to their shop as it's on the main ramp. And so, unfortunately, the isolated automation area started at the portal. So, by allowing the groups to go to work early, that meant shutting down our truck early. So, we had multiple days where the groups were kind enough to delay their work by 30 or 40 minutes, but it was difficult to continue asking them to sacrifice their time without receiving some sort of pushback from them. And then in this process, we realized the additional personnel that would be required to sustain the program. So we would need to increase the number of staff, our electricians especially, to help maintain the infrastructure underground, and then making sure we had a sufficient number of trained operators dedicated to running the automated equipment. So getting the employees on board with the whole project proved to be difficult at times. There was so much cooperation required from many different groups, and without that cooperation, we wouldn't have been able to complete the work. The operations group supplied the haul truck, the maintenance group supplied an empty bay in the shop for us to do any work needed. The electrical group helped support the network infrastructure underground. So we really had to try to minimize the disruption to their work as much as we could to keep making progress on the project. Another problem we ran into was determining how to load the trucks at the bottom of the mine and have them ready to tram to the portal. The shape of the ore body at the bottom of the mine makes it really difficult to install any sort of chute or ore pass. So far, the ideas that we've come up with would just be extremely capital heavy, and we just couldn't justify it. For the current setup of the Greens Creek mine and our needs to see the most benefit out of an automated haulage route, we would need to be able to run the automated trucks in sort of a follow the leader style safely in conjunction with our manual operation. So have an operator in truck number one with two automated trucks behind us would be the most ideal situation. But unfortunately, that is not the level of technology that we've reached in the mining industry and for most industries for that matter. For the time being, we've put the project on hold until technology advances enough that we can utilize it on shift like that. And finally, just the lack of automation standards was an unexpected issue that we found. There doesn't seem to be many standards and regulations to follow in this process, so we were forced to create our own, which may have actually kind of hindered a lot of our progress along the way. So since we've implemented automation at Greens Creek, we've updated and added various procedures to our work, some of which were set in motion by certain incidents. An incident that kept happening repeatedly was the setting up of automated equipment in an area where personnel were still working. It was an area where there were multiple working faces and the gate was located back in the main access. And so the automated loader was set up on one side of the intersection while another face miner was working on the other side. And this is considered an extremely high risk situation as the equipment will not recognize a human as an obstacle, as a human does not fall into its environment margin of error, which I believe is about a 10% variance. And so a human just doesn't have enough surface area to show up on that reading to a loader. And so thankfully, the furthest we've gotten into the setup process in all of those incidents was simply firing up the loader to test the system to make sure everything was working. The loader had never moved from its parked location But this specific occurrence, however, was one that forced our general manager to shut down all automation operations until we could come up with a solution. The root cause of the incident was deemed the failure to follow proper heading clearing procedures. We have heading clearing procedures for blasting, so we had just been using the rough similarities between the two to clear automation headings. But after these incidents, we modified our SOP for heading clearing to include all of our automation scenarios. After that, all of our mine crews were retrained on this new procedure. We also created an automation clearing checklist form, and this form was to be filled out by the shifter and anyone involved in the clearing and equipment setup process before setting up any piece of equipment. Another incident that happened during the haulage route project happened when the truck would stop on the route for whatever reason, either at the end of its segment or if it lost Wi-Fi connection. When it stops, it initiates the e-brake. However, if left on the ramp like that, there is no one around to chock the tires or rib the equipment. And our ramp system is really complex enough that certain places on the ramp have access both above and below. So if an employee were to happen upon the truck from lower access on the ramp and it wasn't yet chocked, it puts that operator at risk. And so the solution to this problem was to notify the shifter of the truck location on the ramp wherever it stopped. And then the shifter would send someone down there immediately to either chock or move the truck to a safe location by accessing it from above on the ramp. The shifter would also notify personnel to avoid the ramp area below the truck until it had been moved. While trying to implement automation in as many areas as possible around the mine, we began requiring more and more field cabinets to install at the automation gates. And these field cabinets are fairly expensive to buy directly from Sandvik, so in order to cut costs, we found that we could build the cabinets in-house at a fraction of the price. But during one of the pre-check tests done at the portal gate during the haulage route project, it was noted that once the gate was set and tripped, it didn't actually break the safety signal and shut down the machine like it was supposed to, which means the machine just kept going. And Sandvik strongly recommends that we use the products provided by them as they meet or exceed safety standards in the industry. So for the future of automation at Greens Creek, I do think Hecla will continue to look for different ways to bring technology into the workplace to improve both safety and production at the mine sites. We've seen the benefits of automation and its potential, and we'll keep working towards the future of the mining industry as technology continues to advance and the challenges we've encountered are addressed. So that is everything I have for today. I do appreciate the opportunity to present. I do wish I could have presented live, but please feel free to contact me with any questions or comments anyone might have. Here's my contact information, and enjoy the rest of the presentations.